My name is Kshitij Sood, and my student ID is 012483666. And today we are going to play with Amazon's ec2. So, so the basic requirement for the Lab1 is to set up the user account in the selected cloud technology, create an application, and then we have to deploy that particular application on the selected cloud technology. That's in this case is Amazon's AWS. So we will measure our application performance on various metrics, and for that we will be using Amazon's CloudWatch. So basically we will be measuring like disk read and write, network in, network out, CPU utilization, memory utilization, and we will also set up various alarms, and we will also configure various custom metrics also. So let's start. So this is the sign-in page of AWS. This is the home page of the AWS console. So here's my account details, and here's my dashboard. So I'm using ec2 free tier, and as well as I have this student account, so under which I got around $100 credit. So right now my month to date balance is $0, and these are the details of the top free tier services I have used so far. So for ec2 I have used it for 11 hours. That's almost 1.47% of the free tier hours that I've got. So this is the forecasted value, which is great. And similarly, these are the forecast and month to date actual usage for EBS volumes, S3 puts, and KMS request. So now we are going to launch an instance of ec2, and currently we are in US East North Virginia zone. So let's start then. So the name of instance can be anything. So now we have to select the operating system. So I'm going ahead with Ubuntu 14.04. Yeah, it's eligible under free tier. So we are going to select 64-bit distro. We'll be selecting T2 micro with 1 CPU and 1 gig of memory, and it only supports EBS volumes. So we'll be configuring our EBS in the coming stage. So number of instances 1. We don't want any spot instances. Network is default. Subnet we don't want to change. IAM role, this is none. And so basically IAM role is basically a service that runs on the top of AWS. So you can manage various services using this thing. So we're going to add storage now. So we'll be adding only 8 gig of memory, 8 gig of storage, and it's a SSD. So next we will add some. We will not add tags here. And under the security group, we will allow SSH from anywhere, and we will also add a rule for our application, because we will be deploying an application on this instance. So we have to define another rule here, like we will allow all TCP connections from anywhere. Okay, so review and launch. Now you can here see that we can review various things like instance type, security group, and instance detail. Before launching the instance, we can review these details. And currently my instance is open to any IP, so anyone who knows my IP address can access my instance. But we can also change that. Under the security group, we can say that I don't want to open this instance to all of the IPs. I can create a custom IP list here. Okay, so launch. So now we are going to generate a public and private key that we will use to log in to our instance from our local machine. So we'll create a new key pair. Let's call it CC Lab1 ec2. We will download it and we'll launch our instance. So our instance is now almost ready, so it's in pending state, and so no IPv4 address has been assigned yet. So it will take around 1 to 2 minutes to fully fully come in a ready state. So this is a status check, and these are the basic metrics I was talking about. And currently we don't have any tag. So now let's see our EBS block store. So EBS block store is in use right now. So the status check, so the volume status is okay. So the under monitoring, you can see that there's nothing in the cloud metrics yet. So hopefully it will refresh itself in another 5 minutes, and we can see some read and write bandwidth here, because our machine is just being created. So our instance is up and running. So let's try to log into the instance using SSH. So okay, so no, that's the thing was the permissions for this CC Lab1 ec2, this private key was too open, so we have to change the permission to 440, and now hopefully we can connect to our instance. Okay, we are in our instance. So currently there is nothing in it, and now we will try to install some stuff so that we can deploy our application. So I'm going to install UWGI server and Falcon. So we will build our microservices on the top of UWGI and Falcon, and in the backend we will be using MongoDB. That's a key value store. And what we are going to do is we will just dump some random data in our MongoDB, and we will try to fetch it using our API. So there will be two APIs, one for post and one for the get, and thus we will measure our application performance on CloudWatch. So let's start by installing some Python modules. Okay, let's try apt-get update first. I will install UWSGI. Okay, so Python setup tools is not installed yet. We will install UWSGI, and then we will install PyMongo, which is a Python driver for MongoDB, and we will install Falcon, and then we will install MongoDB in our instance, and then we will deploy our application. Now for MongoDB in Ubuntu 14.04, we have to add this key store. And okay, so we have to create a DB path. Okay, so MongoDB is up and running, and so we will create a collection, but not right now. Our application already will create a collection as well as a DB by itself. Now what we're gonna do is we're gonna I've already created this application here, HTTP. So it's nothing but it's written on the top of Falcon and UWSGI. So here's our routing file. So we have defined only two routes, get dump and get all dump data. So get dump, uh, it should be post dump, because this will we will this thing will post data to our MongoDB, and we can pull this data using this API. So this is our service file. So the get dump, so for the dump data we have defined on get and on post method. So on get, we will do nothing, but we are just dumping hello and yeah. So we will not use this. We will use post to post the data, and we will use all dump data class to pull out the data from our MongoDB. And so we have defined a Mongo connection here, and this is the dump data method that will insert data, and this is the get all dump data method that will pull out the data from the MongoDB using offset and limit. So let's transfer this project to our server. Let's build this project. So our test API egg has been deployed. Now we will try to run this UWSGI server on top of it. On the top of UWSGI server. So we have this. So I have this basic configuration in my local machine. So our UWSGI server will run on 8057 port, and there will be a max of 12 workers that will be available to process our request. So let's SCP this configuration file to our instance. So now we can see the uwsji.ini file. That's the configuration file for our uwsji server on our ec2 instance. So let's try to run this server. Okay, so our server is up and running, and now we'll try to dump some data. So this is uh, the sample URL from which we are going to dump the JSON data into our API. So this is nothing but it's a comprehensive data set from the NASA about all the meteorite landings. So this is a pretty huge data set, and the main purpose of dumping this data is to see some metrics on AWS CloudWatch. So let's dump this data. Okay, so there's an issue with our WSGI server, I guess. Okay, so okay, so it's underscore app. So let's try to add data again. Okay, it's working now. So we can see the incoming request in our EC2 instance. Okay, so I guess the process is completed now. Yes, so now so we have created a test DB on our MongoDB, and this is the collection where we have dumped the data. Let's see one sample record. So this is a single document, and there are about 47,000, around 47,000 documents in our collection. So what we're gonna do is we're gonna get this data using our APIs. Okay, so now we have fetched this data from our API, just a single record. Let's try to fetch it again. So a single record was fetched in 197 milliseconds, and let's try to fetch 10 records from our API. So these are the 10 records, and now we will fetch the whole data. So it will take some time because there are too many records. So definitely now we will see some metrics in our CloudWatch, because there's there's a huge network out going on, and obviously we'll see some disk read and writes operation, and CPU utilization operations too. So now we have fetched the whole 44,000 something records in 10 seconds from our MongoDB, and let's see the metrics now. So this is our instance, and okay, so there are two status checks available uh, under our ec2 instance. So one is system status check, another is instance status check. So the basic difference between these two checks is that the system status check monitors the AWS system, and like if the data center is down or there's some power outage, then this system check will not pass. So this is fine right now. And what is instance status check is that it monitors the health of our instance. like let's say if our operating system gets crashed, or the file system gets corrupted, then this instance status check will fail. That is the our machine is not reachable. So right now these two are okay. Let's monitor some logs. So this is basically a CPU utilization percentage. So we can see a steep rise in CPU utilization. It was a time when our instance was created, and we can see a steep fall in the steep CPU utilization, and then we can see a linear graph, because we were doing nothing between this period of time. So we were doing something, but we were not usually utilizing CPU so much at the time. So there we can see a steep rise again. So let's see some other metrics too. So this is a network in and out, network in metrics. So again, there was a steep rise, and then there was this steadiness for a couple of minutes, and there was steep rise again. Okay, so and we can monitor statistics by there are various uh, parameters on which we can see the metrics, like average, minimum, maximum, uh, and sum. So it's quite useful. So let's see the metrics for our EBS block store. So the status check is okay, and this is the read bandwidth. uh, like we can see the average here. So it was 0.24 in the beginning, then it was 0.05, then it was this, and then there was again this slight increase, and we can see the read throughput. So for the last this is definitely due to this uh, this is definitely due to API call that we have done. So and there are other metrics available too, like average write size and average write latency, and idle time spent. So they're quite useful. So what we can do is we can create our custom metrics in using Amazon's CloudWatch. So for that we have to go to the dashboard, and we have to create another dashboard. Let's call it custom metrics. Okay, so now we will create metrics for our ec2 instance only. So our ec2 instance is, we have to find the instance id. So instance id ends with 0e. So this was the old instance that I was using, but it's no longer available. So this is our present instance. So we will create a graph for, let's say, network in, network out, and disk read operation, so which is not available because we are using EBS store. So network packet out we can create, and we can create CPU utilization graph too. So we can create a widget here, and we have to save this to our dashboard, and we can monitor this custom metrics whenever we want. So and there's also a and one more thing, there's a bunch of this custom things we can do here. Like we can monitor the matrix in for, say less for the last 45 minutes, or we can do it for like 5 minutes, which is so the data is not available for the last 5 minutes yet because we are using the free service. So let's change it to 15 minutes. Yes, we can see the data. So we can create any number of metrics here. Another feature is the alarm. So alarm is basically this monitoring service of AWS. So we can create an alarm and we can say that we can define some action, and we can define various parameters for that particular alarm, like when to when should the alarm be invoked, and I'm going to show you this stuff. So let's create an alarm for our ec2 metrics. So our instance id ends with OE. Let's create an alarm for CPU utilization. Let's say let's create an alarm for network out. So in the last few minutes, so our network utilization was 3.3 like 3.33 MB. It was max during this time. So we can create an alarm for, let's say, we can name it network alarm, description network alarm ec2 lab. So uh, so so here's the condition: whenever there's network out and it's greater than or equal to, let's say, 2 for consecutive period. Okay, it's 9,000. Okay. So the alarm will be triggered when blue line goes up to or above the red line for a duration of 5 minutes. Okay, so we can still increase it, let's say, to 90,000. Okay, so the alarm will be triggered when the blue line goes up to or above the red line for a duration of 5 minutes. So if we change the period, let's say for 2 consecutive period, so our period duration is 5. So the alarm will be triggered if this condition is met for consecutive 10 minutes. So let's say we want to do it for just one consecutive period, and what action to take when this alarm changes state. So whenever this alarm state is alarm, then send a notification to when we can create a new list here. So network alarm list. Okay, so network alarm list. Okay, so we can add email IDs to notify, and we can create an alarm here. Okay, so I do have to verify this thing to confirm my subscription to this network service. So now my alarm is saved now. So currently there is insufficient data. We'll monitor this alarm later. Let's create another alarm. So we will create an alarm for our instance, let's say CPU utilization. Okay, so utilization CPU greater than 1. Let's say if the CPU is greater than, CPU utilization goes above 1, then we will trigger this alarm. Let's say for 2, then we will trigger this alarm. Okay, for consecutive 1 period. So so the alarm will be triggered when this blue line goes up to or above the red line for a duration of 5 minutes. So we can use our old notification list and we can create an alarm. Okay, so right now both these alarms don't have sufficient data, so uh, it will take some time. uh, and we can create another events too, like we can create a alarm for billing, like if our total AWS charges exceeds, let's say, $2 for a month. So right now this is my current AWS charges, zero, since I am using a free tier account, free tier account, and I have $100 credit in my AWS account. So we can send a notification to various peoples regarding that, regarding the AWS charges. So this is pretty cool service. And uh, okay, so one of the alarm state is okay right now. Let's see. Let's refresh this page. So the network alarm is okay. And if we want to change its state, let's dump some data again. And let's try to pull the data from our APIs. So okay, so now we have pulled every record from our MongoDB. It took around 14 seconds. Let's see if our alarm was invoked. Okay, so the network alarm was invoked just now. You are receiving this email because your Amazon CloudWatch alarm in US East North Virginia region has entered an alarm state. So we can see our alarm here that both CPU utilization and network alarm uh, were invoked because we pulled so much data from our API. So now we can see that our CPU utilization was like 11.82% and our network utilization was 10.4 MB. So our APIs. So this was the brief introduction to AWS, about how to create an instance, how to set up alarms, how to monitor your instance, how to create custom metrics using CloudWatch. Thank you.